Today, we discussed the term 3 Past Year in 2022, question 19. A parallel beam of monochromatic light is passed through two slits as shown in the diagram. So this is the interference pattern. Both slits separated by the distance of 1.4 times 10 to the negative 4 meter, and the distance of the slits from the screen is 2.5 meter. Bright fringe at A, okay, A is here, is 2.07 centimeter from the central fringe. Sketch a graph to show the variation of light intensity with distance from the central fringe. Okay, so this should be easy, 2 marks. Okay, so it should be sine wave. Okay, maybe some of you might consider to draw a rectangular wave, which is also maybe true for me. Okay, but this should be the answer, okay, the sample answer from me. Okay, not the official lah. Okay, so we shall move on to the next question. Determine the frequency of the light which pass through the slits. So quite simple. We have the formula, okay, the formula for the interference pattern. Okay, you need to know that the default by default is the lambda equal to AX over D. And to relate it to the frequency is you can apply the formula of C equal to F lambda, where C is the speed of the light in A. Okay, so there's nothing mentioned about the medium. So we can assume that the light is travel in A in this case. Okay, so we have the value of C, okay, multiply D over AX, okay, where C is the speed of the light. And we have the value of dA, but X is slightly different from what is given. Okay, so we can see that the bright fringe at A is 2.07 centimeter. Okay, so this is the distance of between two bright fringe, which is we have 2x value in between. Okay, so we need to divide the value given by 2, and then everything is the same. So just apply the formula, and we can get the frequency is 5.18 times 10 to the power 14 hertz. So question number 3, determine the path difference between the light arrived at B from two slits. Okay, so this is the second order of minimum fringe. Okay, so from what we learned about the destructive interference, okay, so this is the dark fringes, so it's a destructive interference. The path difference should be m minus 0.5 multiply lambda, where m equal to 1, 2, 3. Okay, so for B, it is a second order, where m equal to 2. So what we have is that the path difference is 1.5 lambda. Okay, so for lambda, okay, you can just also, again, you can apply the formula of C over F, okay, where F is the one we have here. Okay, so put in all the value, you should obtain the answer is at 0.69 times 10 to the negative 7 meter. Move on to question B. Monochromatic light with wavelength 572 is incident from A on a thin salt film. The thin salt film has a refractive index of 1.3. Calculate the wavelength of the light within the thin salt film. So this can be related with the phenomenon of refraction. Okay, we want to know that what is the wavelength of the light in the thin salt film. Okay, so from the A into the thin salt film, it is the refraction. Okay, so we are given with the refractive index, wavelength. So how do we relate these two variables to help us solve this question? Okay, so from what we have learned in SPM, okay, the refractive index is the ratio of the speed of the light in A to the speed of the light in the medium. Okay, so this is what we learned in the refraction. Okay, so we also can relate the speed with using the formula of V equal to F lambda. So you can see that the velocity, okay, or the speed is directly proportional to the wavelength. Okay, so this is what we need. So to conclude, we have the refractive index is the ratio of the wavelength in A to the wavelength in the medium, which is the thin salt film in this case. So just apply this formula that we have the wavelength of the film equal to the wavelength in A divided by the refractive index, and you should be able to obtain the answer is 440 nanometer. Okay, so if you get the concept, easy 3 marks for you. Next question, calculate the minimum thickness of the thin slot film that produces a constructive interference for the reflected light. So this is one of the topic learned in STPM. Okay, so this is how it looks like. So we learn about the reflection. Okay, from a denser medium, it causes a phase change of pi. So this would contribute to the path difference. Okay, so for the medium below the thin slot film, it should be the salt. So it should be a denser medium compared to the thin film. So there'll be another phase change of pi here. So the path difference between the red and the blue, okay, so there's also a similar question discussed before, is 2 and t. Okay, so both have the phase change of pi. So the only path difference is from here to this point back to this point, which is 2 times nt. So to have constructive interference, we have 2nt equal to m lambda. And to get the minimum thickness, we have the m equal to 1, okay, which is the first order. So put in those values and should be able to obtain the thickness is only 220 nanometer. So that's all for this question. Thank you.